Well, the first things first, the naming of the mechanism. It's quite clearly going to be electrophilic addition, forming hexene, cyclic alkene, and we've got two structural isomers. Okay, and the big key takeaway is that reacting with a hydrogen halide to form the two structural isomers, and the HBr is a hydrogen halide. So the mechanism, well, it's not your average mechanism. Because these type of mechanism questions, I see them pop up more often than not. But it's with this kind of structure, and it is a bit more complicated. I definitely struggle with these a lot more compared to, you know, your average mechanisms where it's with the displayed formula. But in this case, when it's in the skeletal formula, I really struggle with it. But all we're going to do is going to draw this out, and we know this reacts with HBr to form two structural isomers of, and it's going to form this, the major product, and we're trying to outline the mechanism for the formation of the major. And then what happens is that double bond goes. We still have this methyl group attached in the top, but it has a positive charge here, and the bromine, the minus charge in lone pairs of electrons, bonds, and then you form your major product. But you obviously don't need to carry on from there. Then 4.2 draws skeletal formula of the minor product, forms the reaction in question 4.1. Okay. And you also, quick mistake, it should be from the double bond. We're trying to show the curly arrow. From the double bond, that's really key as well. But the rest of it should be fine. Not from, you know, here, no. From the double bond, which is out. Then, so now we're trying to skeletal formula the minor product. Well, the minor product skeletal formula is going to be 1, 2, 3, 4, 5, 6. Methyl group still here, but the Br is now here. And then explain why the products are formed different amounts. Classic question, and even if you know what the question wants you to ask about, even if you don't not really that confident on the topic, but you still know what it wants you to talk about, you can still maybe get at least 1 or 2 marks. But the idea is obviously of carbocations. Well, it's formed via more stable carbocation. How do I know this? Well, it's because it's the major product, so it must be formed via more stable carbocation. That's just a generic statement, and that will give me 1 mark. The major product. Now, which formed from which kind of carbocation? It is going to be tertiary carbocation. Yeah, tertiary carbocation. Tertiary carbocation. I might make a video on how to identify using the cyclic structures, because I struggle with it a lot. Maybe you guys do as well. Yeah, so formed rather than secondary carbocation, and the stability comes from greater positive inductive effect as more alkyl groups. Now, this part you could always basically copy and paste into any kind of real question that involves you to talk about the stability. Greater positive inductive effect as more alkyl groups. Like, just memorizing that will put you in a better position when attacking these type of questions. And then where it's like where products from different amounts, or why the stability of products, etc., etc. Then says draw structure of the major product and excess HBr reacts with limonene. So limonene is this. So what's going to happen is that we're going to have a BR here, and we're also going to have a BR here. So it's going to be this, BR here, and the BR there. So BR there, original structure, and the BR there, and the double bonds are obviously removed. And that is the end of question 4.